what do you think is the most common type of land use we have today on our planet? When I ask these questions to my students, I usually get different answers. Forest land, cropland, deserts. In very few cases, I get the correct answer, which is grazing land, pasture land. If you look at the distributions of land uses we have today, you can see that 37% of the global ice-free land is used for grazing land, either intensively or extensively, but it is the most common type of land use. Then we have managed forest with 21% and 12% of cropland. And by the way, more than half of this cropland is used for production of animal feed. We are now in a situation where human activities are affecting more than 70% of the global ice-free land. And we are now left with something less than 30% of land that is unused, and nearly half of it is desert. If you look at the historical trend, you see an expansion of managed areas over time. We are therefore in a critical situation where we have conflicting or sometimes multiple demands from the land, which is a limited resource, because we rely on land products, food, feed, materials, fresh waters, to support our society and our economy. And at the same time, we need to preserve land for biodiversity and ecosystem services. And on top of this, we have climate change. Climate change is already posing challenges to the processes and dynamics in many types of land. We have 1/3 of the land which is degraded, and we have, in this report, you will find a lot of information concerning the relationship between climate change and land. But climate change is also important for the land from another perspective. If you are familiar with the previous report from the IPCC, it is becoming increasingly important the role of land and land management for climate change mitigation. Because for climate change mitigation objectives like the 1.5 degree stabilization, you have to expand forest, you have to expand bioenergy crops, and those are additional demands for land, which are on top of an already quite tough competition. And another consideration that we should keep in mind is the difference in average temperature rise between land areas and the globe. The globe includes the oceans. The land has warmed nearly twice as much as the global average, because the land warms faster than the oceans. If you look at the historical records, you can see that the average temperature rise at the global level, land and oceans, is about 1 degree Celsius since the Industrial Revolution. And over land areas, this is around 2 degrees. And of course, this is a consideration that applies not only to the past, but also to the future. Whenever you hear speaking about the 1.5 target, the 2 degree target, which would be a great success to stabilize temperature at 1.5. But over land areas, this means an average increase of about 3 degrees, or even more in the northern hemisphere, where you have the well-known amplification of the climate feedback. And in the report, you will find an assessment of the challenges from the land and the effect on vegetation properties and functioning from a changing climate, how much it has affected yields and productivity, and also for extreme events. But what I decided to focus the remaining of my presentation on is the interactions that we have among the land system, the climate system, and the society. I therefore need to introduce the concept of the shared socioeconomic pathways, the SSPs. The SSPs, in very simple terms, are future scenarios that are considered by the IPCC to investigate possible future developments of our society according to a range of assumptions. For example, you have SSP1, which is the Sustainable Development Scenarios, which is perhaps the most optimistic pathways, where you have a prompt green transition, you have an easy implementation of green and renewable technologies into the market, you have a stabilization of global population, you have high income and high economic growth, but you reduce inequalities, and you have international regulations for land use, and you have changes in diets, dietary shifts towards less meat consumption. This is opposed to SSP3, which, on the other hand, is a scenario where you have high population growth. By the end of the century, here you achieve a population level that is twice as much as what you have in SSP1, which of course is associated with higher demand, higher pressure on terrestrial ecosystems, and you have relatively low economic growth, large inequalities, you have barriers to trade, and you still have quite greenhouse gas intensive lifestyles. Another scenario is SSP5, which is a scenario where you have high economic growth, high income level, but our lifestyles will still be quite energy intensive for some times, and we still use fossil fuel for quite a good numbers of years, with opposed to the SSP1. And therefore it is interesting, and what you find in this report is how land use changes will happen in the future according to these different set of scenarios, and how they relate with climate change mitigation objectives. We can start by looking at SSP1, which is the most sustainable scenarios, where you have here a visualization of the land trajectories that are consistent with the climate stabilization at 1.5 degrees. What you see here is the time dimension over the horizontal axis, and then you have the relative change in land from 2010 in the vertical axis, and please pay attention to the unit, million square kilometers. What you have here in the color shades are the range of the different models for the different land use types, and the solid line is the mean. Positive values indicate an extension of the land cover, negative values is a reduction in that land cover for that particular land use type. What we can see here is that under a sustainable future, we will have practices into play for having more efficient food and agricultural production system. We will have climate smart agriculture and other measures to close the yield gaps in many African countries, so we can be more efficient in producing food. We will have less food waste. We will have changes in diets with lower demand for livestock products. This, of course, will have an effect to reduce the amount of land that is used for cropland and for pasture. And in this context, it becomes easier, or I would say more cost competitive, to have land for climate change mitigation objectives, to sequester CO2 from the atmosphere or to produce energy that we need in our economy. And you can see the increase in forest areas and the increase in bioenergy crops. And within this context of sustainable developments with international regulations and a lot of cross-sectoring actions, you can see that you will see that the implications for food security, land degradations are relatively low. So the risks to increase conflicts with the land challenges is lower with respect to other scenarios that we will see in a while. It is also, but of course it is a challenge, because you can see the ramp up that we have in the land use changes from forest and bioenergy crops. To give you an idea of the scale of the challenge, by the end of the century, forest areas here will expand up to 7.5 million square kilometers, more or less is the area of Australia. Bioenergy crops up to 4.5 million square kilometers, which is half of the United States of America. And if we look now to the other scenarios, which is a more resource-intensive scenarios where we have still greenhouse gas-intensive lifestyles, you can appreciate the difference, which is an earlier, a stronger ramp-up and deployment of bioenergy crops. Because to achieve a 1.5 degree target, we have high energy demand from the society, which has to be met. And further, what you have in this scenario is that after 2040, bioenergy crops are supposed to be developed together with carbon capture and storage, CCS. So coupling bioenergy and CCS into what is called BECCS is a key option for SSP5 or for more resource-intensive scenarios in order to be consistent with the 1.5 target, much more than what you have for SSP1. And within this context, of course, the risks that we can have from land competition, for food security, for land degradation, are higher than what we had before. And of course, now we can have a variety of considerations and different aspects, and we don't have now the time to go into the details. But we can just reinforce the concept that climate change mitigations, for climate change mitigation, it is central the way in which we manage our land. Land management is key for climate change mitigation objectives. And also we need the portfolio of the different climate change mitigation options. They should not be seen in competition to each other. We need both forest and bioenergy crops that are sometimes seen in opposition to each other. You have different needs at different local levels, and you don't have one-size-fits-all rhetoric, but you need to consider the local context. Because we have a choice. We have a choice regarding the type of risks that we can take from future warming, depending on how our socioeconomic system will develop. You can see here from this risk map, where the color of the red is proportional to the intensity of the risk. You see that the risk for land degradation or food insecurity for the same level of warming, 2 degrees, for example, is different if we will develop in a world which is in line with SSP1 or closer to SSP3. And the same for bioenergy. We have seen before how much climate change mitigation pathways rely upon large scale of bioenergy deployment. But you can see here, for the same scale of bioenergy deployment, the risks that you will have in terms of environmental damage, here shown as an aggregated indicator, is different if you are in SSP1 or if we are under SSP3. We have a choice on the type of risks that we can experience. The decisions that we will take in the next few decades will determine the pathways where we will be. And in the report, you find not only an assessment of the historical past and the present conditions and these types of land dynamics for large-scale climate change mitigation objectives, but you also find an assessment of a variety of options. Improvement options in the report are called the response options that can be taken today or in the near future by different authorities at a local level or at a regional level to implement the land challenges you have in the different context. To name a few, we assess more than 40 options about afforestation, that is expansion of new forests, avoided deforestation, dietary changes, or reduction in food waste, and so forth. And for each of them, you will find an assessment of how well they contribute to climate change mitigation, adaptation, desertification, land degradation, so that you can identify synergies or co-benefits or trade-offs of each of these options. And then, of course, we also assessed the cost. Because these options are not for free, they have a price tag associated with it. But what was clear from the literature we reviewed in these 2 years is that we need also to factor in the cost of inactions, because the deferral of greenhouse gas emission reductions implies significant economic damage in many regions of the world. And prompt action could reduce the risk to millions of people from climate extremes, desertification, land degradation, and food insecurity. And it is also clear that the longer we wait, the higher the cost will be. So, should we still be talking about cost, or we should rather call it investment? Thank you.